Hello everyone, good morning. So we are here to present our final project, which is diabetes prediction. So now I'm going to present my part, which is introduction. So diabetes is a chronic health condition that affect millions of people worldwide. It is caused by a problem with the way the body produces or uses insulin, a hormone that irregulate the amount of glucose in the blood. We present a logic regression model for predicting diabetes using a dataset obtained from data.world. The model is trained and tested on the data set and is evaluated using a variety of evaluation metrics such as precision, recall, F1 score, and accuracy. The report also includes an analysis of future selection and a comparison of the model's performance with other models.
Data. The, the diabetes prediction dataset is a comprehensive collection of patient information that is commonly used in the diagnosis and management of diabetes. The dataset was obtained from the data.com Data.world, a platform that hosts a wide range of open datasets. The datasets contain a total of 391 data points, provide a rich source of information for training and evaluating machine learning models. The datasets include 15 features for each patient, including patient number, laboratory test result, and demographic information. The outcome feature of the dataset is a diabetes, which is a binary variable that indicates whether or not the patient has been diagnosed with the diabetes. The dataset is a valuable resource for researchers and practitioners in the field of diabetes, and it can be used to train machine learning models to predict diabetes based on patient information, providing a useful tools for healthcare professionals in the diagnosis and management of the diabetes. This is the database prediction datasets for the pre-processing. The diabetes prediction datasets pre-processing thus required a number of stages. First, a label encoder in Python was used to turn the outcome features diabetes into a binary variable. The missing columns were discovered using the data frame info method. This method easier to spot any columns with blank values, and those columns were then handled appropriately. This pre-processing task helped to prepare dataset for training and evaluating machine learning models, making it ready for the analysis. This is the pre-processing part.
So for the methodology of our project, our approach involved two main steps, which the first one is we use chi-squared method to select the best feature for our model. Chi-squared is a statistical test that measure the relationship between two categorical variables. It allows us to identify the variable that have the greatest impact on the outcome of interest. In our case, is diabetes. By using chi-squared method, we are able to narrow down the number of features we used in our model and increase the accuracy of our prediction. Next slide. This is the graph for the bar graph for the feature selected. There are top 10 features selected. Next. So we employed logistic regression to classify the prediction of diabetes. Logistic regression, is a powerful statistical method that is widely used in the field of medical research. It allows us to analyze the relationship between the selected features and then likelihood of developing diabetes. Logistic regression takes into account multiple factors and allows us to estimate the probability of an outcome, which is essential for our diabetes prediction model. by using these two methods together, we are able to achieve higher level of accuracy in our prediction. We are able to identify the most important factors that influence the likelihood of diabetes and use them to make more informed prediction. Next. So for the results, the first step is we created a confusion matrix. In evaluating the performance of a model, we use several confusion metrics, which including precision, recall, and F1 score. The precision of class 0 patients without diabetes is 0.82, indicating that when the model predicts no diabetes, it's 82% correct of the time. The recall of the class 0 is 0.75, meaning the model correctly identifies 75% of patients who don't have diabetes. So the F1 score of for class 0 is 0.72, which take into account of both precision and recall. The support of class 0 is 12, indicating that the 12 patients in the test set without diabetes. So similarly, precision for our class 1 patient with diabetes, it's 0.96%. Recall is 0.87, and F1 score is 0.96, and the support is 66. So the overall accuracy of our model is 93% accurate. Next slide. So this is the confusion matrix that are created by our classification. Next.
As for the ROC curve, in the diabetes prediction model, the ROC curve was plotted using the true labels and predicted probabilities for the test set. The area under the ROC curve, which is AUC, is 0.9, which indicates the model has a good ability to distinguish between patients with diabetes and patients without diabetes. This is the ROC curve. The receiver operating characteristic curve is a commonly used visual tool for evaluating the performance of binary classification models. The ROC curve plots the true positive rate against the false positive at various threshold settings. Okay, as for the learning curve, a learning curve is a graphical tool used to evaluate the performance of a model as the training sample size increases. In the diabetes prediction model, the learning curve was generated using the learning curve function from the sklearn.model underscore selection module. The results of the learning curve is shown in the figure below, with the blue line representing the training score and the orange line representing the validation score. The learning curve provides an additional evaluation metric that helps to visualize the model's performance as the training sample increases. The learning curve indicates that the model's performance improves with more data, but it does not show signs of overfitting. So this is the learning curve, and you can see that the blue line and the yellow lines are placed based on, according to the data.
Conclusion. In conclusion, a machine learning model for diabetes prediction can have a significant impact on the diagnosis, management, and treatment for the diabetes by accurately classifying individuals as having diabetes or not, identifying risk factor for the development for diabetes and predicting the progression of diabetes. The model can help to improve the overall management for the disease and reduce the risk of complication. Building such a model requires a careful consideration of the problem, data, and the technique used. Data collection, pre-processing, future engineering, and model selection are the key steps in the process. Thank you.